last video, we introduced Attrasoft image deep learner, which is an off-the-shelf deep learning software. We introduced the end product. Looks like this. So if you want to make a search, so simply select the image and make a search, and then you can find matching images. So that's we introduce the end result of the deep learner. This time we're going to talk about what a deep learning is before we start to use the software. Before that, let's talk a few basic concepts. So we go to help. Let's go to this section of the user's guide. We introduce the concept of feature, concept of representation, and the concept of feature engineering. To solve an image recognition problem, the problem has to be formulated into a standard form. Very often this form is a table. And if we look at this table, we have some attribute as columns, and then we have images. For each image, you calculate these attributes, and the collection attribute is a computed feature or feature. And these features together forms we call the image signature. And this process to formulate a problem in terms of this table is called feature engineering. Okay, so now let's talk about what is deep learning. Deep learning is basically the fourth iteration of learning. The first is programming, the second is machine learning, the third is representation learning, the fourth is deep learning. So at the beginning of the problem is solved by programming. We call it first iteration. Now to increase productivity, so we introduce machine learning. So the problem is no longer solved by programming, but solved by learning, in the hope that it will speed up things. It turned out that before you can apply learning algorithms, you have to go through the process of feature engineering introduced earlier. And people find a good algorithm for machine learning, but the feature engineering still requires manual labor. So in this stage of machine learning, we increase productivity by roughly 10%. That naturally points to the next evolution, which is automatic feature generation. And the next iteration is called representation learning. In the representation learning, everything is automatic. So you have automatic feature generation, automatic learning algorithms. You solve the entire problems by a few clicks. No programming is required. That's all very good, except occasionally you will run into some structure problem. Like these two images basically same, except the distance between them. So ideally you will have one layer study this, grab this, one layer grab this, and then put the two layers together on the top. So that create a hierarchy problem. And that's deep learning. So deep learning will have many layers. Today we build these layers manually, but each layer is a fully automatic process. So within a layer, there's no manual programming. It's just how you put the layer together. And that's deep learning. Our software supports 3 different architecture: 3-layer, 4-layer, 5 layers. And they linearly stack together like this. So let's go back to the software. So we have 3 options, option A, B, C. Option A has 3 layers. So if I do go to second layer, it's right here. This is option A, layer 3. Then option B has 4 layers. Option C has 5 layers. The layer 1 is all common. Layer 1 is basically identify lines, identify curves. That's the same. Also in deep learning, the last layer is always the same. The first layer is always the same, identify lines. The last layer is pretty much the same. They are basically supervised learning layers. Basically, you tell the machine what is a match, what is not a match. And the machine, you have to pass the concept of match and not a match into the machines. Okay. So let's briefly talk our option A, 3 layer, 1, 2, 3. So layer 1 is identifying lines. Layer 2 is basically a representation learning layer. It creates features for you from the image data automatically. So all what you have to tell is how many features from a folder of images. For example, I'm going to create 30 features from a particular folder of image right here. And then when you do this over and over again, get enough features, and then we go to next layer, supervised learning layers. So that's basically architecture A. It's complete automatic. It's basically a representation learning with the 3 layers. The option B has 4 layers. The layer 1A is still identify curves. Layer 2 again is still the same. You compute some features from the images from raw data. The next layer will compute features from the early layer of features. So the computing features from features versus layer 2, which is computing features from images. And in option B, the last layer is again a supervised learning layers. In option C, we have 5 layers. Layer 1A, layer 1C is still same thing, computing lines. Layer 2C will compute features from images. Then this layer 3 compute feature from features. 4 compute feature from features. 5 supervised learning. Now you are asking, why do you need to compute a feature from features? Actually, as you go up, as you move up the ladder, the detailed information become blurring. So at the lower layer, you see this is car A, this is car B. At the upper layer, they're all cars. So it's for concept identifications. So to summarize, we have a 3 deep learning architecture, 3 layer, 4 layer, 5 layers. And each layer is a tab. And all the first layer is universal. In deep learning, all the first layer is try to identify lines. All the last layer is the same, the supervised learning layers. In the middle layers, they are all feature layers. They are all automatic feature layers. So you basically, here's the data, grab me this many layers for me, it will go out, do it for you. In the next video, video guide, we will talk about how to prepare data. There's no programming involved here. Every layer is buttons, so you basically click few buttons. For example, in this layer, you select some folder of images, say I'll get this many folders, and then grab this many features. And then you can do some check. You will do this process over and over again until you get enough features. It's all automatic. The next layer, you do supervised learning. Everything is automatic. But we do need to prepare data so we can get this process going. That's the purpose of next video guide. We'll show you how to prepare data. After that, we're ready to use the deep learning software. See you next time. Bye.